Hello guys, what's up? I'm Foad, back with another video. Today is kind of about programming. It's more about computers. Today we're gonna be looking at the components of a CPU, what's inside it, and how it actually operates. You may ask why we are going to learn these. I think it's really important for a programmer to know how a CPU operates, because I know a lot of software engineers who are experts in their fields, but they don't even know how CPU works. It's just the fundamental stuff, and I think it's pretty useful for you to learn how it works, and it will also widen your programming horizon, which I think is really good. So that was it for the introduction, and let's jump right into the explanation. Alright guys, as you can see, our computer consists of a couple of major components. Our input devices, our CPU, which is our central processing unit, our main memory, which is our RAM, or as people tend to call it, random access memory, our memory storage, which is where we store our actual data, and our output devices. There's an important note that I'm gonna tell you. See, we have our random access memory and it actually stores data in it. But the point is that it's not where we permanently store our data. When we turn our computer off and turn it on, our RAM will be reset and it will be cleared and nothing will be in it. So the actual data, like the documents and stuff that we store in our computer, are going to be stored in the secondary storage, which might be a hard drive or SSD. But today we're going to be specifically looking at our CPU or our processor or our central processor unit. Now, the purpose of a CPU is like our brain. It processes all the instructions and it operates the whole computer. So it's a very important part if you think about it. And without a CPU, you won't be able to do anything with your computer. You won't even turn on. Now, a CPU consists of many different parts like ALU, cache, registers, or even a control unit, which are the things that we're going to be discussing later in the video. So let's take a look at some history about the architecture that I'm going to be explaining to you.
Boring!
In 1943, early computers used to store the data in the memory and fetch them and do instructions in them. But in that year, a mathematician called von Neumann have introduced a new concept of programming. He said that we can store the instructions and the data both in the same memory and execute them and work them together. And that was where stored program computer was born. And today we're going to be discussing the architecture of stored program computers. As I've said earlier in the video, a CPU consists of many different parts such as the cache, the registers, the control unit, and etc. But let's first take a look at registers. And you may ask, what are registers? And
that's what I'm going to be explaining.
Alright, before I explain the registers, I want to give you some rough idea about how a computer works. You see, you have instructions. When you program, you see those lines, those are all instructions, and they will be stored in the RAM. And RAM is like a table with many different rows, and each row has its own address. And if you want to access it, you have to know the address of it. And if you know the address, you will be able to look at what is inside of that special row in your memory. So that's basically how a RAM works. So now let's explain registers. Registers are more like a very small but very, very fast memory to help the CPU to operate. We have many different kind of registers which I'll be discussing right now. One of the registers is called program counter. And what it does is that it stores the address of the next instructions that is going to be executed. And then we have memory address register. The memory address register is a register that holds the address of the instructions, the current instruction that is going to be executed, and the data that it needs, so that they can be fetched together and go to the ALU to be processed. Then we have the memory data register, and this register holds the actual data that the memory address register was holding the address for. You see what I mean? So it stores those instructions and data. And then we have the accumulator, which holds the result of an instruction that has been executed before it goes to the memory. Now, another part of the CPU that I've named was ALU. And ALU stands for Arithmetic Logic Unit. And what it does is that it does the arithmetic operations like adding stuff, subtracting stuff, multiplying stuff, and dividing stuff. So don't worry if you are having problem to understand these, because when I give an example, it will be clear all for you. Then we have the control unit, and what it does is that it controls the units. The control unit coordinates and controls all the activities that take place within the CPU. It decodes instructions and executes them, it receives signals from the system clock, and it directs the timing and control of other parts of the CPU, much like a brain. And it directs the timing and control of other activities that take place in the CPU, much like a conductor. So now that you have rough idea about what these parts of the CPU are, I'm gonna bring my laptop and set an example for you so that you understand them better. Alright guys, here is a diagram of the components that I've explained to you earlier in the video. As you can see, we have the program counter over here, and what it does is that it holds the address of the next instruction that is going to be executed. And I assume that you know that a RAM is like this, and it has different rows, and each row has an address. For example, let's say this one has 0, this one 1, this one 2, and when we say that the row number 0, we're referring to this row. Sorry
for my bad handwriting. I'm using my mouse to draw these, so sorry for that.
Now, let's say that we want to add two numbers. In the row number 0, we have number 4, and we want to assign it to B. And in number 1, we have A. We want to assign 6 to it. Then we want to add 4 to 6. And then we want to print it. Alright, so our program counter will currently have 0 in it. So our memory address register will look at the this one, which is the row number 0, and tell our memory data register to have a look at what is inside it. And our memory address register looks at it and sees that it says 4 plus 4 is equal to B. Then it will send that instruction to our control unit. Our control unit is gonna decode it and execute it. And what that means is that, for example, here, if we want to add 4 to 6, it's gonna send 4 to the accumulator. So our accumulator is gonna be 4 right now, with this path as you can see here. Now, our program counter will add 1 to it, and remember that
every time that the fetch, decode, execute cycle happens, our program counter, we will add 1 to it.
So now it's gonna be number 1 stored in it. So our memory address register is gonna look at this and tell our memory data register to have a look at what's inside of it, to have a look at its content. So we look at it and send that information to our control unit, and it will say that we want to have, for example, 6 stored in the variable called A, and let's say that we want to add both in this instruction. Our control unit will see that, all right, we want to add these both of these together, so we will need another data and tell our program counter to give me that data, and our program counter will be added 1, it's going to be 2, this whole cycle is going to continue, and our new data, which is this one, is going to be fetched to our control unit. So what this line says is that we want to add A and B together, or 4 to 6. So now it will send that instruction that has been decoded to ALU, and our ALU will remember that the instruction is plus 6. So it will read that and apply it to the accumulator, and it will become, our accumulator is now gonna become 6, not 4 anymore. And when the next cycle happens, our program counter will go to the next line, our memory address register will go to the next one, so that our memory data register will go there and see that instruction and send that instruction to our control unit. Now our control unit will take a look at it and say, all right, this instruction says that we want to print it. So send that instruction to our ALU, to our accumulator, and our accumulator variable, which is currently 6, is gonna be stored in our RAM so that it later can be printed. So by this path, it will go to our ALU, then to our memory data register, and that means that the memory data register will put it in our RAM. It's such a messy diagram. And that's how basically we add two numbers together in our CPU. Now the point is that many like billion of these instructions happen in every second, so that you have your computer right now working in front of you. Alright guys, that was it for today. I really hope you enjoyed and you've learned something new. I'll leave some links to some resources about this topic so that if you want to practice more and learn more about this topic, you can go ahead and learn. The links are gonna be in the description below. And if you've enjoyed, consider subscribing to my channel. I have lots of awesome videos like this coming up soon, and have a nice day.